Good morning friends, welcome to Parnika tutorials YouTube channel. In the last few videos I have discussed how to construct the LL1 parsing table. In this video I will discuss how the LL1 parsing algorithm will works, and with the support of parsing table how it will construct the parsing tree. All these things I will discuss in detail. So if you look at the LL1 parser, if you look at the LL1 parser, it will take the parsing table, which is LL1 parsing table, okay, and even the input buffer or the input symbols it will take in the buffer, whatever the input string you want to take, and with the help of the stack data structure, it will give you the output as parsing tree. Because any parser, the final output it will give the parsing tree. So it will use the parsing with the help of the parsing table and the input buffer and the stack data structure. Is it clear? Are you able to understand? So we will discuss about the entire process with this example. Okay. So now what I have done is that I have taken a one grammar, okay, consists of S determines A, capital A, B, B. A determines C, epsilon, B determines D or epsilon. First, if I want to construct the parsing algorithm, I need to construct the parsing table for this grammar. Then I will take the input string, and with the parsing table, I will construct the parsing tree. So, our first objective is to construct the parsing table for this grammar. So, how to construct the parsing table? First, I need to identify the terminals. What are the terminals here? You have a A, you have a B, you have a C, and you have a D, and you will have the dollar. Will you agree with me or not? Okay, these are the terminals will be there in the columns of the LL1 table. Okay, am I right or wrong? Now at the rows, you will have the non-terminals. The non-terminals here is S, A, and B are the non-terminals for this grammar. What are the non-terminals? The symbols which are there in the left hand side of the productions, we will call them as non-terminals. Okay, let me construct the LL1 parsing table for this one. So how it will be? S determines this A, B, B, where I should keep this production. I need to compute the first of A. First of A is A only. So here I need to keep the production called S determines A, B, B. Is it clear? Are you able to understand? Because this production is in the form of A determines alpha. A determines alpha can be kept in the terminals. How is that? You need to compute the first of the alpha. What are the terminals are there in the first of alpha? There you need to keep the production. So I have computed the first of A, because this entire one first will be this one only, because it is starting from this one. Am I right or wrong? So first of A is A only. So in S and A location I have kept the production. Coming to this one, A determines C, where you will keep? You will keep it in the first of C. First of C is C, so you will keep here. Now A determines epsilon. Where you will keep? You will keep it in the follow of A. Follow of A will be first of B. First of B is D comma epsilon. You will not consider epsilon. In place of that one, you will keep epsilon here. You will get the B. I hope it is clear for you. By this time, I hope you know how to compute the follow. So that's why I am not taking much time for computing the follow. Let me discuss again. Follow of A is, you need to look at where A is there in the right hand side of the production. Here it is there. After that, whatever the symbol is there, you need to compute the first. If you look at the first of D, B is D comma epsilon. If you have epsilon, you will not keep it in the follow. In place of that one, here if I keep epsilon, then this production will be A, B. Am I right or wrong? So follow of B is small b, because first of B is B only. So you need to keep the production A determines epsilon in B and in the D. Will you agree with me? Similarly, I need to check about this production. B determines D. I will keep it in the D only because first of D is D. And B determines epsilon, where I will compute the follow of B. How I will compute the follow of B? I need to look at where B is there in the right hand side. Here it is there. Compute the first of the next symbol. First of the B is B only. So you will have the follow of B is B. So you will keep the B determines epsilon here. Is it clear for you? Now you look at it. Can I erase this one? Now if you look at it, you have these are the undefined entries. What these entries will be called as errors. If you look at any defined entries where more than one production is there, here only one production, here only one production, here only one. So everywhere defined entry you have one production. So I can say that this grammar can be parsed using LL1 parser. Am I right or wrong? If anywhere if you have multiple entries, in the last example also I have discussed. Am I right? If you have multiple entries, that grammar we will say that we cannot parse using LL1 parser. Okay? Is it clear? Now what I will do is that I will take one string which can be generated from this grammar. Okay? And then with the help of LL1 parsing algorithm, how the parsing tree will be constructed, I will discuss in detail. Okay? Now if you look at it, the simple one string is possible is A. In place of this A, I will keep C. I can keep C or epsilon. I am keeping C. In place of B, I can keep D or epsilon. I can keep D. I will get this one. So this is the string possible over this grammar. Now for this string, okay, what I will do? I will keep it in the input buffer. This parsing table I will take and I will give to the parsing algorithm to generate the parsing tree. So I will have the stack. Okay, I hope it is clear for you. I have a stack and I have the input symbols or the input buffer. Is it clear? Are you able to understand it or not? We have the stack and we have the input buffer. So in input buffer, you will have this string called A, C, D, B. At the last, you will keep the dollar. Why you will keep the dollar is that to say that the string is ending. Whenever you are accessing the dollar, the meaning is that the entire string is finished. So it represents the end of the string. And as I said earlier, always the stack will consist of the symbol dollar at the bottom of the stack. Okay. Now, when we will finish the procedure is, when the finally the input pointer is pointing to dollar and you have the dollar here, then we will finish the process. Now input pointer is pointing to the alphabet A right now. And even we will push because it is a stack, we will have two operations, push and pop. So that operation I am not writing here. Okay. First we will push the start symbol. What is the start symbol for this grammar? S is the start symbol. I will push the S. Is it clear? I request everyone to please watch it with more concentration. Okay. Now you have the stack symbol S. Okay. Now your top of the stack is this one. Am I right or wrong? So you look at the entry. Your top of the stack is a non-terminal and your input symbol pointer is pointing to a terminal. So whenever you have a stack top symbol is a start non-terminal, whether it is a start symbol, obviously start symbol will be a non-terminal only. If it is a non-terminal, then you need to look at the table where this entry S on A, what is the entry is there. Let me discuss again. Your top of the stack is a non-terminal and your input pointer is pointing to a terminal. So you need to look at the parsing table on this location S on A. If you look at it, S on A, this production is there. What is this production? S, A, B. Am I right or wrong? Yes, A, B is there. So you pop this S. Okay. you will pop, the first thing you will do is that you will pop the S, okay, and you will push this one in the reverse. Is it clear? B, B, A. Is it clear? Are you able to understand it or not? Let me repeat again. You are looking S on A. What is the production is there? S determines A, B is there. So, pop this S. In place of this S, keep this right hand side one in the reverse order, so that your A will come on top of the stack, because your stack will look like this. Am I right? Right now you have dollar and yes. You are popping the S and you are pushing this one such a way that B, A will come. Am I right or wrong? Is it clear? Are you able to understand it or not? Now your top of the stack is this one. Your top of the stack symbol is this one, and you have A, C, D, B. Is it clear? Are you able to understand it or not? Okay, now listen carefully. A and A, there is a match, because top of the stack is a terminal A and your input pointer is pointing to A. There is a match. Okay, I will write it here. There is a match. If there is a match, you will pop this one from the top of the stack or from the stack. Now your top of the stack is pointing to this one. Your input pointer will point to this one. Is it clear? Or let me write it that your input buffer is consists of this one, for your understanding, because it has traversed this one. Is it clear? How many members have understood? I don't know. Your top of the stack and the input pointer, whenever it is matching, you will remove the terminal from the stack and you will shift the input pointer. So now your input pointer is pointing to the C. Is it clear? Now your stack is consists of BBA. Now your top of the stack is a non-terminal and your input pointer is pointing to this one. What you should do? Whenever the top of the stack is a non-terminal, then you need to look at A and C in the LL1 parsing table. Is it clear? Are you able to understand it or not? A on C, you got the C. Okay? A on C is your C. Is it clear? So, what you have to do? You have to pop the A and then you have to push this C, where C is a what? Terminal. Are you able to understand? Please note down parallelly with me so that you will understand the concept in a better way. Now your top of the stack is this one and your input pointer is pointing to this one. There is a match, so you will pop this one. Is it clear? Are you able to understand? You are popping this one and your input pointer is pointing to this one. Is it clear? Let me write here. Your input pointer is pointing to right now currently D. See, I am not removing the input from the input buffer, just to make you understand that I have traversed A and C. Here A and C is there. My input pointer is pointing to this one. But here I am pushing and popping. Now if you look at it, stack pointer is this one, top of the stack. Okay. And you have a non-terminal. Whenever you get a non-terminal on this one, you look at the parsing table. B on D is getting a production called D. So you will remove the B or you will pop the B and you will push the D. Is it clear? Are you able to understand? As you have only one symbol in the right hand side, whether you are pushing in the reverse order or front order, it will be D only. Am I right or wrong? Is it clear? Now if you look at it, your stack symbol is D and your input buffer is pointing to D. Again there is a match. If there is a match, what should I do? I have to pop this D, okay, and the input buffer will be pointing to, your input pointer is pointing to B. Now if you look at it, again there is a match. Am I right? Because B is a terminal here and it is also B. So there is a match. Again you will pop it. Your input pointer is pointing to dollar. Now what I can say? I can say that the string is finished and your stack is consists of only bottom of the stack, which is dollar. So I can say that the procedure is finished. And now I will discuss how we will get the parsing tree. Excuse me. Okay, now finally you should get the parsing tree. Now let me discuss how you will get the parsing tree. Okay, let me erase something. Okay, let me use this space. Within this space I will do it. Now when you are in the top of the stack is yes, so your stack symbol is yes. Is it clear? Are you able to understand? Parallelly the parsing tree will be done, but as I want to explain this entire process and then I want to construct the parsing tree. Now yes on A, what is happened? You used this production, so you will get A, B, B. Is it clear? Are you able to understand? Next you have looked at this A. A on A, which production you have used? A on A, you used the production called A determines C. Am I right or wrong? So from A, you are determining the C. Is it clear? Then you looked at B on C, not B on C. A on A, you got it what? On C, and C matched. Then you looked at B on D. Here you are looking B on D. What is the production you used? D. So from B, you are generating the D. Okay, and that's all. And B on B, there is a match. So how you will do is that if you yield the parser, you will get A, C, D, B. How you can remember is that, or how this procedure will actually happen is that when you are looking a non-terminal here and a terminal, what is the production you are pushing, that production you will do here in the parsing tree. Am I right or wrong? The places where we have looked at is here and here. Am I right or wrong? This is the place we looked at, and what is the production we use from yes, that production I have written here. Similarly, I have used here A on C, I have checked it. Am I right or wrong? A on C, because this one was popped that time. The small a and a, there is a matching, and then we have done A on C, I have done here. This production A on C I have pushed, so I have written here. And similarly B on D, I have used this production D because I was pushed into the stack. Whenever you are pushing the right hand side of any production onto the stack, there you will do the derivation in the parsing tree. At the same time, it will happen if you are pushing onto the stack, the meaning is that you are deriving it in the parsing tree. I hope with this example you have understood from a given grammar how to construct the parsing table, then using the parsing algorithm how to get the parsing tree. Is it clear? Now I will have a one doubt. Let's take that simple example. Let me give a small example. Okay, now here you are looking B on D, you got the D. Let's take that here in place of D, just an example. In place of here you are looking a here. Let me take an example. Here B on A you are looking. B on A, there is an error. Am I right? Whenever you get a error here, the meaning is that this string, whatever the string you have taken, cannot be generated from this grammar. Are you able to understand? Let me repeat again. Here we have B on D, we use this one. In place of D, if I consider here as A, let me take it. Here I have taken A, then I will get a here. Now B is a non-terminal on the top of the stack, and you have a terminal in the input buffer. Now B on A, you need to look at the entry. Now if you look at it, there is a empty. So what is undefined entry will call error. Whenever you get a error, then you will say that this string cannot be derived using the given grammar. Is it clear? I hope you have understood how the parsing algorithm will works. If you still have any doubts, don't worry. In the next video, I will take one more example and I will explain the parsing procedure and how to construct the parsing tree. Thank you for watching my video. Have a nice day.